Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of linear relationships. This is standard 8.5C in the great state of Texas, and we are using item number 13 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got some scatter plots here, and there's going to be two words that's going to be important for us. First, which scatter plot does not suggest a linear relationship? So that is not defined anywhere on your answer document. It's not defined in this problem, so that's a vocabulary word we need to know going into this problem. And if you ever forget, you could just look at the first four letters. A linear relationship shows you a line. Specifically, we need a straight line, not a curved line. And so even though it's pronounced differently, line to linear, changes the vowel sound. Linear simply means it's a straight line. And so there's two different ways that we've been getting straight lines in 8th grade. So y equals mx plus b, that's the slope-intercept form. So that is an equation that gets us straight lines. And we've also used this right here, y equals kx, and that's direct variation. Now these vary in just one major way, even though one is an m, one is an x, or one is a k, they're both slope. It's this right here. The slope-intercept form has a y-intercept, which means it is non-proportional. You notice there is no y-intercept in our direct variation, which means it is proportional and it goes through the origin. But both of those will get you straight lines that kind of look like this. So that's what we've been dealing with. If you want to start getting curves and bells and different types of things, you need to add some exponents to that variable. And that's what we get into in Algebra 1 and beyond. So in 8th grade, we're dealing with just straight lines. And so that's what we're really looking at. So that's one word we need to see. The other word here says suggest. So think of it like hint, kind of softens it right there. It's going to be not exact. It's almost like approximates or estimates. So it's not going to be 100% perfect, like you can plot it like it's an exact line that you can calculate the slope. We're just looking for a general direction, a general straight line. So which one does not suggest, which means 3 of these are going to have a straight line or going to suggest a straight line. Really what we're going to use is we're going to use a trend line. So that gives us kind of an approximation of what direction, what a slope might even be. So you kind of start at one end and you're trying to get right through some of these dots, but if you see that you've got like these two right here, we're going to go straight in the middle between those. So sometimes you go on the dots, sometimes if they're kind of spread apart, you try to go right through there. You see how that kind of hints at a straight line, but it's not 100% straight because obviously you got some of these dots that don't necessarily land on the line, but the line goes in between them if they're clustered together like that. And we've kind of got the same thing working with B. Just trying to get down here. Now these last two we can get on the line. And so that looks pretty close to straight line. It looks like I curved it just a little bit, but that's still pretty straight-ish, right? We're going to ish this, straight-ish. Now C, wow. There's no doubt about C. C is definitely curved. So that is probably the one that we're going to select because that is definitely not in either the slope-intercept or the direct variation. D almost looks like it's straight without any slope. Actually, it looks like it has just a hint of a downward slope. Might be more evident if we took it out a little bit beyond that 10x. But A, B, and D all represent a straight line, or at least suggest it. So our answer here is C.